Hi everyone, I'm Jade Comellas and I'm a PhD candidate at the University of Hawaii working with Dr. Shiv Sharma. I'm so grateful to have been given the Poorman-Hoyt-Stratford Foundation ARCS Award in Earth Sciences to support my studies while I finish up my PhD. I'm originally from Santa Fe, New Mexico, and I grew up obsessed with both rocks and outer space. So when I discovered that you could combine the two and study rocks in outer space, I was amazed and knew right away that that would be the right path for me. I am currently part of the Mars 2020 Perseverance rover team, specifically the SuperCam science team, and we study the geology on Mars using the spectroscopic techniques on the SuperCam instrument, which is located here on the Perseverance rover on Mars and also on the LEGO set. More specifically, I study minerals that have formed through the interactions between volcanic rocks and water, which was once very abundant on the surface of Mars. In fact, if you look at this Mars globe, there was enough water to carve massive valley networks that can be seen from space all over the surface of Mars. One of the more interesting minerals, in my opinion, that I study is called serpentine, which is formed from a different mineral called olivine when it undergoes what is called hydrothermal alteration, which is basically adding water and heat for long enough to change the chemistry of the rock. In this process, which is called serpentinization, hydrogen is produced as a byproduct. Hydrogen is thought to be very important for early microbial life as it provides fuel and could contribute to the warming of the planet through greenhouse effects, causing Mars to host a more habitable environment. We don't know definitively whether life has ever existed on the surface of Mars. The possibility is fascinating though, and the more we explore, the more indications we see that life might have once actually thrived on ancient Mars. To identify olivine and serpentine, we have been using various spectroscopic techniques, such as laser-induced breakdown spectroscopy to determine the composition of the rocks we analyze, visible and near-infrared reflectance spectroscopy to determine the types of minerals and molecules present in those rocks, and Raman spectroscopy, which is my favorite, and it can be used to also identify specific minerals. The Raman spectrometer on SuperCam has identified minerals such as olivine, carbonates, and even quartz. So with this generous ARCS award, I will be able to travel to the Mars 2020 team meeting this summer, where I can present my research and collaborate with other scientists from around the world. This award will also help fund the additional analyses on the terrestrial analog samples, which in turn will greatly support SuperCam's ability to identify serpentine on Mars and help unravel the mysteries surrounding past habitability. So thank you so much for this honor and opportunity, and thanks everyone for watching this video.